I've encountered this integral while doing some black hole calculations, and it is a beast. It looks easy and quite innocent, but you will see we will need a couple of tricks to solve it. Let me share how I did it, and let me know in the comments how you would do it. First, I tried to simplify the integrand by extracting the scalar factor a out of the integral and getting rid of the x in the denominator. The integral changed but did not look easier, so it is time for the second step. The numerator of the integral looked a little bit like the derivative of the denominator to me, with some changes, so I added 0, and this gave me the opportunity to create two integrals out of one. And those two integrals, I called them Alice and Bob. So now we have doubled our work. We have to solve two integrals. Going good so far. Alice is quite easy to solve. First, we take a look at the square root in the denominator and take the derivative of it. This shows us that the integrand is the derivative of the square root in the denominator, and this means the integral is just the square root. So now that we have found out what this integral is like, we can go on to Bob. Well, Bob. We are adding 0 again, because it looks a little bit like the binomial formula. And this time we're doing the adding of 0 inside of the square root. This changed the integral to the following. And now we see the binomial formula. Here x squared plus bx divided by a plus b squared divided by 4a squared, and here x plus b divided by 2a and the whole thing in brackets squared. So we are performing some little transformations now to simplify the integrand a little bit, and then we can finally perform the hyperbolic substitution. Well, the hyperbolic substitution, how does it look like? What we're going to do is we're going to say that the cosine hyperbolicus, the hyperbolic cosine, is equal to 2a divided by b times x plus b divided by 2a, and then we calculate the infinitesimal element dx in dependence of d psi, and we will find out that dx is equal to b over 2a times the hyperbolic sine of psi times d psi. Then we plug that into our integral, and the integral enormously simplifies, because cosine squared of psi minus 1 is sine hyperbolicus squared of psi, and then we have the square root out of it, so we in the end get the hyperbolic sine divided by the hyperbolic sine, and the integral simplifies to d psi, which is just psi. And all we have to do now is plug in what psi is, and it's just the inverse hyperbolic cosine of 2a divided by b times x plus b divided by 2a. And that's it. We just need to plug that into our final solution of the integral, and then we will find out that we have as a solution 1 divided by the square root of a times the square root of x squared plus bx divided by a, and then minus b over 2a times the inverse hyperbolic cosine of 2a divided by b times x of b plus 2a. So the integral looked quite easy, but as you can see, we get an insane term. I told you, it's a beast. Let me know in the comments how you would solve it, and yes, thanks for staying with me. I hope you liked the video, and please leave a like. That will help me a lot with the algorithm. Alright, see you in the next video. Bye!